So continuing on, we're going to now get into some of the details of some of the specific endocrine glands. For this one, we're going to focus on the pituitary gland, hypothalamus, thyroid, and parathyroids. So we'll go through a couple sections here. Now, by the time we get through this, we're going to look at the interrelationships of anatomy and functions of the hypothalamus and the pituitary glands. We're going to talk about the 2 hormones released by the posterior pituitary, their targets, and then look at the 6 hormones produced by the anterior pituitary, their targets and actions, and how we regulate when via the hypothalamus. So this is what we're looking at here. If we take a little close up, here's the hypothalamus right down in here. Right. We have the infundibulum, which is going to be like this little stalk that connects the hypothalamus to the pituitary, and then the pituitary can be kind of sectioned off into 2 parts, the anterior lobe and the posterior lobe. And they do have different jobs, which is why we make that separation. So here is our list of the pituitary hormones. If you notice, the anterior kind of has a bigger job, right? It got the promotion over posterior. It produces a lot more hormones, including growth hormone, prolactin, thyroid stimulating, adrenocorticotropic, follicle stimulating, luteinizing hormones, right? Long list. While the posterior is only going to have antidiuretic hormone and oxytocin, both of which are not even produced by the posterior. They're produced by the hypothalamus and only stored there. So we have some differences in terms of what we do. Again, I'm not going to sit here and read this to you because you can pause here and read through if you need to. So by all means, pause and read through if you would like. But the big thing we see is that we see thyroid stimulating hormone, follicle stimulating hormone, adrenocorticotropic hormone. We notice that a lot of these are controlling other endocrine glands. So again, like I said in the last video, you can think of the anterior pituitary as the middle manager. It is going to kind of serve as a managing gland for all these other endocrine glands. And having all those steps in place gives us a lot of places to stop the process or to regulate the process. So it's nice to have all these extra steps so that we can impact a certain stage to stop if we need to, or we can stimulate something to say, yes, let's go. The one down at the bottom too, the intermediate zone, or is going to produce melanocyte stimulating hormone. This is going to stimulate melanin formation, melanocytes. This is not something I'm going to worry about too much. So let's look at how we're wired up with the posterior pituitary. We're going to start there and then we'll go to the anterior. So in this case, here's our hypothalamus, right? And we see ADH is produced as well as oxytocin are both produced in the hypothalamus. And they're going to follow along this hypothalamo-hypophyseal tract. What a name, right? If we break it down, hypothalamo, think hypothalamus, hypophyseal, because the hypophysis is another name for the pituitary gland. So hypothalamo-hypophyseal tract, right, is going to be just the pathway that links the hypothalamus and the posterior pituitary. Right? So we are going to send those, and we're going to store them within the posterior pituitary, and then the posterior pituitary will release oxytocin and antidiuretic hormone as needed. On the anterior pituitary side, right, in this case, right, again going through that infundibulum, but we see that the hypothalamus is actually going to release a hormone that is going to stimulate the anterior pituitary, right? So hypothalamus releases a hormone to stimulate the anterior pituitary, then the anterior pituitary can release its own hormones that it does produce, right? That laundry list of hormones. And depending on the signal it gets from the hypothalamus will trigger the anterior pituitary to create and release different hormones. Now here's our summary in terms of like what affects what. We are creating the oxytocin, we are creating the ADH in the hypothalamus, and those get stored, right? That can get stored in the pituitary. And with ADH, antidiuretic hormone, this is going to impact anything that uses like or handles a lot of water, so your kidneys, your sweat glands, your circulatory system, and this is to help retain water to affect water balance, to make sure you don't lose too much water. Fun fact, when you drink alcohol, one of the effects you may experience is having to urinate more often. That is because alcohol can inhibit the release of ADH, so you don't actually recapture as much water in your kidneys, so more water ends up in your urine, and so you end up dehydrating yourself. It's one of the reasons why you can feel like crud the day after a night out. Right? And that's also why, like, if you've ever paid attention, if you haven't, maybe do so, that if you've been drinking, you may have noticed that your urine seems especially clear compared to normal. The oxytocin, this is also known as like the cuddle hormone. This mainly, though, is targeted for the female reproductive system for childbirth. In the anterior pituitary side, we have all these releasing hormones from the hypothalamus, right? Gonadotropic releasing hormone. These are all, like, these long lists. I'm not going to have you memorize this entire list, but just realize that there's various hormones that are released by the hypothalamus that will cause various hormones to be released. Right? So like the corticotropic releasing hormone will then stimulate adrenocorticotropic corticotropic hormone, and that affects the adrenal glands. The gonadotropic releasing hormone will trigger luteinizing and follicle stimulating hormone to be released by the anterior, right? So we see like this trend, right, where there is a hormone that will trigger the release of a hormone that will trigger the release of potentially another hormone. So we can have these chains, right, of one hormone causing the release or affecting another, causing the release of another. Again, if you want to pause here, you can do so. That way you can read through this, but I'm not going to pause here too long, so we've already spent enough time. Now let's go ahead and get into the thyroid. The thyroid, we're going to talk about the location, the anatomy of it. We'll talk about thyroid hormones in terms of your basal metabolism, and then we'll talk about the hormone produced in the follicular and the parafollicular cells. So this is the thyroid. It sits just below like your larynx. It's, again, this butterfly-shaped gland, right? And so we have the two kind of like wings of it, and they're going to be connected by what's called the isthmus of the thyroid, which is this little skinny part in between. And again, it's resting right around, kind of hanging out with your carotids. And on the very back of it, we see the parathyroids, right? These four little circles, these little ovals right here. And those are going to release their own hormones, but we're going to see how they work in tandem with the thyroid. We see there's various cells. We see there's this colloid containing follicle, which is this like kind of light pink area. We see the follicle cells that line that all the way around, and then the parafollicular cells, which are next to that, right off to the side. So let's go ahead and look at how thyroid hormones are regulated. So one of the big things is how much T3, T4 do we have in the bloodstream. If it is low, right, let's say we don't have a lot of T3, T4 in the blood, then the hypothalamus will release TRH to stimulate the anterior pituitary. Anterior pituitary will then release TSH, or thyroid stimulating hormone. That will then cause the follicle cells in the thyroid to release T3 and T4. And the effect of T3 and T4 is it's going to increase your baseline metabolic rate. This also will increase your body temperature, right? So it's going to increase your baseline metabolism. When these levels maybe get a little too high, the T3, T4 get too high, that's going to inhibit TRH and TSH. So the hypothalamus stops telling the pituitary to release TSH, and the anterior pituitary stops releasing it. If it gets too low, we go through the same process again. Now, there are some issues that can develop with the Thyroid. Now, one of the big things is T3 and T4 are both iodine-heavy hormones. Iodine is a key component to producing those. And so iodine is required in your diet in order to produce them. And if you don't produce them, you can have overgrowth of the thyroid, resulting in what's called a goiter. The picture here with the swelling you see in the throat is the oversized thyroid, what we call the goiter. Right, so we have those T4, T3, or thyroxine, and triiodothyronine, which is T3. Those are going to stimulate your basal metabolic rate. Now, things go haywire with those, whether you're releasing too much TSH or you're releasing too much T3, T4, or not enough. You can end up with hyper or hypothyroidism. Hyper meaning you're producing too much, your basal metabolic rate is too high. Not enough, and you have hypothyroidism, your basal metabolic rate is low. This does have pretty nasty impacts. If it's too low, then that person will have issues with their skin, they'll feel cold, they'll have issues with gaining weight even though they're not seemingly doing anything to gain weight, being tired and fatigued. With hyperthyroidism, it's the opposite. That person is going to feel, at least at first, they might feel great. They're like, I don't need to sleep that much, I feel energized, I'm maintaining my weight or I'm losing weight, I feel I can eat whatever I want. And that sounds good until it starts wearing you down, where now it's turning into anxiety, insomnia, because you're so wound up you can't sleep. That's where the anxiety comes in too. You're losing weight at a dangerous level. You can't keep weight on. You'll have issues with feeling really hot. And something that can happen is what's called a thyroid storm, which is a life-threatening emergency. So I know I made hyperthyroidism sound good for a quick second, but it can very quickly deteriorate into, you go from a high metabolism to dangerously high, to the point where it is negatively impacting your health. The other hormone we haven't talked about yet is calcitonin. Calcitonin is going to lower the blood calcium levels. So the calcium ions that float in your blood, it's going to reduce that. I like to remember it by saying that calcitonin puts calcium in the bones, because that's one of the things it'll do, is it'll help with depositing that calcium in your bones. The parathyroid glands, right, are the last ones we're going to get into for this video, and again, they're going to be working kind of in tandem with the thyroid. Not so much with the basal metabolic rate, but with the blood calcium levels. So we saw that the thyroid is going to increase is going to decrease the blood calcium levels by increasing calcium in like the bones. The parathyroid is going to produce a hormone that does the opposite. So again, we just zoom in. We saw this picture last time, but we're going to look at it again to see those parathyroid glands in closer up. So again, these little tiny circles, they're not very big. They're not really big, but honestly, they don't do a whole lot. They play a very important job, a very important role, but they don't do a lot in terms of range. So the parathyroid is going to release parathyroid hormone, or PTH for short, so I'm going to call it PTH. What PTH is going to do is it's going to increase your blood calcium level, and it can do that by increasing bone remodeling, by breaking bone down. It can also help you absorb calcium from the food that you've eaten, as well as reclaiming calcium from your kidneys. And so I'm not going to go crazy on this picture. You can pause and read through it if you'd like, but the big thing here is this is the teeter-totter or the seesaw example of negative feedback loops. If your blood calcium level goes too high, then your thyroid will release calcitonin to bring it down. If it drops down too low, then your parathyroids can release PTH to bring it back up. So you see how you have two hormones that have competing end effects, right, of increasing or decreasing blood calcium. And so we have this balancing act that we can strike by using these two hormones who act opposite of each other.